Hey guys, welcome back. Today, George is going to talk through how to do fine grading for a residential project and how we do spot elevations and grades and things like that. So let's learn.
Okay guys, in this video I'm going to teach you how to create a grading plan and a fine grading plan for a house. So let's learn. Basically, the first thing I need to share with you is basically the design constraints when we talk about houses and different values. The first one is the minimum paving slope is 1%. The minimum concrete slope is 0.5. We kind of recommend always 1%. The maximum driveway slope in residential, just in residential projects, is less than 15%, but we recommend the slope to be between 1 and 3. The minimum dirt drop is 4 inches or 0.33 feet. The minimum grass drop is 6 inches or 0.5. The maximum change grade in driveways is 5% in 5 feet. The other one is maximum cross slope in the sidewalk. Cross slope is 2%. You can be 0. The maximum longitudinal slope is the sidewalk longitudinal slope should be 0.5 to 5%, and then if you're higher than 5%, you should go to stairs. Now the stair landings are 11 inches or 0.91 feet. The stair rise is 7 inches and 0.58 feet, and that can be between 4.5 to 7.5. The maximum grass slope is 2 to 1 slope, or 50%. And if it is more than 50%, then you need a retaining wall. And the maximum slope in decks and patios are 2% in any directions. You don't want, if you're standing in a deck or a patio, you don't want to feel like you're kind of off balance. So basically, the maximum slope is 2% in patios and decks in any direction. Now, let's talk about the physical constraints of the site. So the first one is the existing contours on the neighboring properties, the existing street elevations, the stream buffers. You cannot disturb in stream buffers, and some counties even have, instead of 25-foot buffers, they do have 50. And the other another restriction is some counties or some jurisdictions don't allow or have an additional 25 feet of an impervious buffer. And another key element is to daylight windows, porches, and patios. So you need to pay close attention to what the architect is telling you. And basically, another important physical constraint is the difference between floors. Normally, the architect gives us, the difference in elevation, especially when you have a basement and a first floor. Sometimes the architect just gives us that difference. So in this case, our architect or the architect who the owner hired to do the architectural drawings, they already gave us that information. In this case, it's going to be, if you see right here, the difference between the finished floor, the first floor, and the basement floor is minus 10 foot 6 inches or 10.5. Okay? So you need to pay attention to that. But sometimes the architect is too early in the process. So basically what happens is, you need to assume, a ceiling for the basement that can be between 8 to 10 feet. It can be 9. And then you need 1.4 feet, 1.5 feet, between joist and floor decking and all that kind of stuff. So basically you need a 1.5, an additional 1.5. So in this case, in this particular project, it's 10-foot ceilings, all right? And then 1.5 for the joist and the finished flooring and the plywood and all that kind of stuff. So in total, it's going to be 11.5. Excuse me, 10.5. Okay? So with that said, let's roll. So the first thing you need to understand is, you need to start working with the restrictions that you have for the site. So the first one is you need to determine the elevation on the road. So you basically pick this elevation. So you know already that this elevation right here, according to the topo, this topo is given, you obtain this topo either from GIS, you can either obtain it from a survey. So in this case, we obtain this topo from a GIS, and this county and this city is Cobb County. So we obtain this topo from GIS. So we understand immediately that this elevation of the road is 80. So that is a restraint. We have that restriction right there. And basically what happens, this is like a horizontal curve. So basically this water is going in that direction. All right. So I am assuming that that cross slope is going to be 2%. So I am assuming if this is 79, this is my contour 79. So I am assuming this will be 2%. So that this is 20. So this means this is elevation right here is at 79.4. Okay. So I already know those two restrictions or those constraints, and then I have this existing topo. Now, from here, I can come down because this is going downhill. So I can come, this is my driveway and this is my driveway. But this is the driveway that is going to be close to the home. So from this driveway, I need to come down, using the rule of 3. I can come right here and see, for example, that I want to come 13%. So I want 13 in and 13%. So I want to come down 0.4. So that means that at 0.4 in this case, well, let's not do that. Let's do first 5%. So 0.4 would be 8. So in this case, I'm gonna do this circle from here. I'm gonna do a circle from here. And I do 8. So 8, and then I have 79 is gonna be right there. Okay, and from that point I need to come 13%. So this is 79. So I need to come 1. So this contour right here is 79. Let's change that immediately so we can use the existing, we can use the proposed contour layer. So this is 79. And then you want to come 13% up to 78 is 7.69. So this will be 78. And then 2 feet, we're talking about 15. So this is gonna be like that. Let me close this a little bit more. Okay, so at 30%, we're talking about 1538, and that's going to be 76. So let's do only 1 foot. $7.69. This is gonna be 77. Okay. Now what happens is this. The house needs to drain. We're gonna create like a swell right here. So the house will drain to that swell. And then the driveway would drain to that swell, and then this water would go in that direction. So basically what happened, we need to create like a low point right here. So, but I'm already coming like 13% right here. Now I'm going to change the slope of right here so it doesn't, it is not too strong, the slope. So basically my intention is to have this elevation right here at probably 76.5, something like that. So let's do it. Let's do it that way. So this is 76.5. So this slope is going to be 0.5 divided by 10. This is going to be 5%. So this is perfect. Now, I have 5% right here. So I need to come probably 2% right here. So this distance right here is going to be almost 9 feet. 9, 2% is 0.2. So that the elevation right here is 0.2 feet higher than that spot elevation I just said it. So this is going to be 76.7. Perfect. So I'm assuming that the house right here is 76.7. Now, and then what happens is if I want to drain that in that direction, then I need to create like a radius centering this point right here. There you go. And I want to create this 20 feet. Even more. Because I need to drain like this from the center of the house. So let's do 30. That is perfect. So what is that distance right there? This is 27. So this is gonna be, I want to drain this at 1%. And basically what happens is I need to make this 76.4 because I want this to be the same elevation of the house and still being able to drain it. So right now this distance is 0.3 in almost 30 feet. Is more than 1%. Perfect. So this water is draining in that direction. Okay. Now what is the slope right here? 77 minus 76.4 is 0.6 divided by 10. It's almost 6%. So that is fine. So I kind of graded this already. Now, according to our, design constraints, my, the door drop is 4 inches. So I want to go higher 4 inches right here, which is 0.3. Now, this elevation right here is going to be 77. Okay, 0.0. Okay, so this means that this deck, this patio, or this porch is at 77. Now, what is my distance between the house and the porch? Is that distance right here. What is the distance? It's going to be 8 feet. So again, 8 feet, then we need to come at maximum 2%. 8 times 0.02 to be at 2% is 0.16. Let's make it 0.1. So the house is 0.1 at the door. So this is going to be 77.1. Okay, 77.1. Now, what happens is, again, according to my restraints, I need to be 4 inches higher for the door drop. So again, my house finished floor elevation needs to be 4 inches higher than that elevation. So 4 inches is 0.33. So I'm gonna make this point, 0.4. You see that? The constraint is 4 inches, 0.33. So my house is to be 0.33. That means that the finished floor elevation of the house is 77.4. So now I know my finished floor elevation for the main is set at 1077.4. Okay, now we know the basement. This is the basement finished floor elevation is 10.5 feet below the main level or the first floor elevation. So I got 1077.4 minus 10.5. So we are, again, 1077.4 minus 10.5. So we have 66.9. Okay. Now we need to grade this side. So we know already, that this water needs to come in this direction. Because this is my high point. Let's do it like that. So this is my high point. So this water going that direction, and I'm taking this water and I'm gonna drain it to here. So what is that distance? This distance is gonna be like 40 feet. It's almost 40 feet. So at 1%, the elevation right here is gonna be 0.4 lower than my high point. So this elevation right here is gonna be 76.3 because it's 40 feet lower than my high point. Now I need to tie this to here. So in order to do that, basically we need to calculate that slope. 1080 minus 76.3 divided by that slope is going to be 44. It's 8%. So we know that we need to come at 8% right here. So let's do it. So basically at 8%, according to the rule of 3, I need to come down 8%. So 8%, my next contour is going to be 78. So I'm coming down 2 feet. So I need to be 25 feet from this intersection. So that elevation right there is going to be 78. Okay. Now what we can do is it can create like a swell and these driveways here, so we kind of direct this water to go to here. Perfect. Let's change this. 77, and then we got 76.3. Perfect. Let's move down to the basement. Now we know that the basement is 1066.9. So this is the doors, from the basement to this patio. So this elevation right here, I'm going to change the color so you know exactly where you're working, upstairs or downstairs. I'm going to change this color to red so you know exactly that this elevation right here is 1066.9, which is the finished floor of the basement. Again, my constraints are, the minimum door drop is 4 inches or 0.33. So from this elevation, 1066.9 minus 0.33, this elevation right here is going to be 1066.57. Now, what is the distance of my patio? I need to measure that distance. 13.9. So 13.9, and then my maximum slope is going to be 2%, 0.02 to make it 2%. So I'm going to 0.3. Let's do 0.2. So the elevation right here on the top is going to be 0.2 below this elevation. Then, hold on one second. It's 0.27. 0.27. So 1066.57 minus 0.27 is going to be 1066.3. So we're talking about 0.27 divided by 13.9 to calculate the slope. So this is 1.9%. Perfect. Now, what that means is all this is at the same elevation of the basement. The patio, this line of the patio is all at the same elevation because it's flat. Okay. Perfect. Perfect. Now we know this patio is at this elevation, which is 10.5 feet below the finished floor elevation of the house, the main level of the house. And this is 10.66.3. So what happens is we have this state buffer, which is an undisturbed buffer. So basically we cannot grade right here. So basically what we'll be proposing will be a foundation wall to come around here and tie the existing and proposed contours. So let's do it that way. Now, from here, this is my existing contour. This is 70. So basically, what I need to do is I need to extend my wall from that corner to here, and then go in that direction. Let me see how. Let me see if I can do this. 0.33. And let's make this. A wall. Okay, another restraint we have for this project is we have these windows given by the architect on the basement. So basically what happens is, let's go to the constraints again. You can see that right here on the basement we have these windows. And according to information provided by the architect, these windows are 2 feet above the finished floor, the basement finished floor elevation. So what happens is, these windows, if my finished floor elevation of my basement finished floor elevation, finished floor elevation is 1066.9 plus 2 feet. So this elevation right here needs to be that elevation right there. It's 3 feet, but we want to have like 1 foot between the bottom of the window and the grate. So this elevation needs to be 1068.9. There's one on that side, and we got another one on this side. Now, obviously this patio is daylighted. At least on this side is going to be daylighted. I think we're going to need a wall right here. So in this side it won't be daylighted, but on this side it will be daylighted. So basically what happens is, we need to provide that elevation and that elevation. That's going to be a restriction that we have, a constraint that we have for this project. Okay, let's keep going. Right now, this is 1070, and I cannot grade. I mean, it's impossible to grade in such a small area. So basically what happens is my 70 needs to come like this. Probably it's going to be like that. I want to make this line wider. So basically we do it like that because we need to keep water away from walls, but we cannot grade on the buffer either. So this is going to be my contour. The proposed contour, that little section is going to be my contour 70. Okay, but we need to be 68.9. Jesus, we need to be lower than 70. So basically what happens is, without having no choice but to bring this contour like that, because we need 1069, 1068.9 right here, and then from here we can be 2 to 1, and then basically what happens is we need to be 1.70 minus 68.9 is 1.1. So we can be 1.1. So my 70 can be like this. Yep. This is my 70 contour. And that 70 is hitting the house. Okay. Now I need to go from 70 to 76, and basically the way we do it is using a 2-to-1 slope. So we need to go down up 2 feet, and basically what I do is I do 4 feet, and that is going to be my 72. Okay, so basically the way we do it is 4 feet, and then this is going to be 72. And then 4 feet. This is minimum, okay? This is going to be 74. I think we got plenty of room on this side, because we need 76. So basically what we can do is have a more generous slope. Instead of doing 2-to-1, we can do 4-to-1. 4-to-1 for 2 feet is 8 feet. 8 feet for 72, 74, and then 76. Perfect. Let's do it like that for the minute. Okay. And on this side, we need to do exactly the same thing. What happens is we got 70 right here. And we got, and this is going to be 77, and this is going to be 76.4. So basically, this water, this elevation right here is going to be the same, because we want to keep this, the house level right here, and we want to keep the house level right here. But this water will drain in that direction. So basically this is 0.4 in this distance. So we need to calculate this distance to see if we are okay. This distance is 4 feet. So we got 0.4 divided by 4 feet. So we got 10%. This is too much. So basically what we need to do is we need to move this over and have this slope. So now we have 0.4 divided by 8.54. We got 4.6%. This is perfect. This is perfect. Now this swell is 40 feet away from the high point. So this swell is okay, because this swell is at 1%. This swell is 4% from the high point, and from the corner of the house is less than 5 feet. But remember, the maximum slope over here is 5%. So this is fine. Perfect. Now we move to this side of the house. So if this is 76 point, basically what happens is, if this is 76.7, as soon as we move to, you know, the grass, remember that the maximum difference between a house and the grass is 0.5. So we got 1077.4 minus 0.5, so it's 1076.9. Okay, but we need to drain this water too. So this elevation right here needs to be 76.5. So we got, in this case, we have this difference of 1077.4 minus, let's do it this way, 77.4 minus 76.5. We got almost 0.9 feet of difference. Remember that the minimum drop in grass is 0.5, but that's the minimum. We can do more. In this case, we have 0.9. So this is perfect. So right now, what we need to plan is to create like a swell. You know, we're taking the water from this high point, taking it to there, taking it to there, taking it to here, and then a swell to go down. Okay, so we got, but we also got this 76.4, and this is 70. We need to drain this water, and this is higher than this one. So basically, we need to come like 2.2 below that elevation, so this water can actually drain in that direction. Okay, if that is 76.2 or lower, we can have lower, but this is 77, and this is 78. So basically what happens is we're going to start connecting. We can also, well, let's grade it this way. So this is going to be 76.2. So that means that my next contour, I mean, let me see if we can, yeah, basically what happens is 76.3 is going to be somewhere in here. Okay. And then from here, we can drain from 76.2, we need to drain it to 68.9. So let's do that calculation. 76.2 minus 76.2 minus 68.9 is going to be 7.3 feet. In what distance? In 30 feet. It's 24%. So let's do 25%. So 25%, if we do 25%, okay, so we need to come 0.2 0.8. So that means that my 76 contour from this point is going to be 0.8. So I have my 76 is going to be right there. So this is going to be 76. Perfect. Now we need to come 2 feet at 25%. So it's 8 feet. Now, basically what happens is I'm going to create like this swell in the middle between the house and the property line. So basically what happens is I'm going to break this line right here, and I'm going to come and create again water away from the house, and I want my bottom of this swell to be 2 feet wide. So I want to go 1 foot in that direction and 1 foot in that direction. So this is my 76. Now, I can copy these 8 feet down. Eight feet is going to be my 74. Another 16 feet. This is going to be my 72. Another 24. And that is going to be my 70. So this contour is 74, 72, 70. Perfect. So I got 76. This is 76.2. So I'm draining this water. I'm draining this water. Okay, very good. And this is 77. So basically what happens is we need to create, we can copy this swell up to here. And let's do it this way. We can copy this up to there. I think this is good enough. Perfect. So we got 78, 77, 76, 74, 72, 70. Okay. And then 68. What happens right here is, you know, we are 1068.9 and this is 1066.3. But remember, the minimum drop for concrete is going to be right here. This can be 6 inches below. So it's 1066.3. 63.3 minus 0.5. This is going to be 65.8. This is like the minimum elevation. You can, you know, 65.8. So let's compare what we have, and this is 1062, this is 1064, and this is 1065.8. So we might need a 64. We need a 64 somewhere in here. Okay. Okay, what happens is, you know, between this 68.9, now we calculate this elevation, we calculate this distance from here to here, 7.9. Remember, the maximum is 2%. So let's assume 8, 1.5% is 0.1. So this elevation right here is 0.1. So this is 0.4. Okay. And this is 1066.4. As soon as you go down outside the this patio, is 0.5 inches. Yeah, it's 0.5 6 inches or 0.5 feet below this elevation. So we're talking about 66.4 minus 0.5. This is 65.9. And that way we guarantee this is daylighted. But this is 1068.9. So what happens is between that elevation and that elevation we need a 68 or a 66, I'm sorry. So basically we need to copy this, and we can come right here, somewhere in here, because this is 1068.9. So basically we can calculate, this is gonna be my 68 somewhere, but we also need another it's too much. This is going to be 68, and then this is going to be 66. We can move this a little. So if that elevation is 65.9, because we need to daylight this part of the patio. So basically we can come 2 to 1, the 2 to 1 slope, and we need 0.1. So this can be almost like 1 foot from this corner. From this corner, we can be 1 foot. And that can be my 66. But I think it's fine, And then we can do 2 to 1 right here. So 2 to 1 again. If I want to go 0.9, this can be 0.5 feet. So let's do 1 foot, 2 feet. Perfect. I think this is perfect. So this is going to be my 68. So we got 68.9 on this side of the window, and on the other side of the window is going to be 68. It is fine because it's basically more than 2 feet from the finished floor elevation of the basement to this window. Okay, so we have graded this side. Now we move to the other side. But before we do that, let's tie this. Basically what happens is you need to tie the proposed contours to the existing ones. So if this contour is 78, look when my 78 is coming. So basically what happens, I think we're gonna need some sort of retaining wall on this side, because this is really far away. And basically what happened, let me see if I can tie it without a retaining wall. Let me see. Basically you need to come like 0.5, 0.5 feet from the property line, and then you can tie your proposed contour to it. This is a construction line. So we tie the existing one to the proposed one, and then we can create that one. Now, this 77 needs to be, this is on, we can do 2 to 1. So we can come 2. We can try to move this swell a little bit more to the right. Or maybe we can have it just 1 foot on the bottom, which is fine. Or 1.5. And total 1.5. You can move this line. This is gonna be my, there you go. And this is gonna meet my 77 right here somewhere. Perfect. This is perfect. I don't need a retaining wall anymore. What happens is this is my 76, so I need to connect this 76 with this 76. And we got all these contours. Look, the 70, I need to connect this 70 with this 70, this 68 with this 68, and this 66 with this 66. So let's just start with the low side. Again, 0.5 feet from the property line, and then we can draw the connection between them. Let's see what happens. This is gonna be my 1066, and then we need to go 2 to 1, you know, up. So let's do 4. You can see it's getting narrower. I think over here we're gonna need a retaining wall. Another 4 feet. You can see we have no swell, so there's no way we can build that swell the way we need it. So basically what that means is we need a retaining wall. Okay, to build a retaining wall, this is gonna be my high side, this is gonna be my low side. So we need, you know, we need to provide some room between the retaining wall and the property line, because you need tiebacks or some kind of, you know, to anchor the proposed retaining wall. So I'm gonna do what will be like the maximum height of the wall. That is gonna be dictated by what happens if we do this retaining wall, probably 3 feet. That sounds about right. So basically what happens is this is going to be my retaining wall. So this retaining wall is going to hit this 66. And that is going to turn, this 66 is doing this operation, and then it's going to turn right here. So basically this existing 66 is hitting my, this is going to be my retaining wall. This is going to be my retaining wall. This 66 is hitting the retaining wall, and then it's traveling in that direction. Now to create a retaining wall, basically what happens is I copy this line really close to that one, to this one. So I'm going to do a 0.1. Now I can trim this 66 with that 66, and then I can trim that 66 with this one. So my 68 is doing this operation, travels along the retaining wall, and then leaves this 68 right here. Now I'm going to copy again 0.1. And look, it's going to go all the way up to here. My 70 is like that. Let's change this to this layer, because this is my 70. Basically my 70 is doing this operation, it's traveling around here, and then it's leaving right here. And then my 72 is doing this operation, and then it's leaving, it's traveling up to here, and then it's leaving like that. Again, one more time. '74 is like that, and it's traveling along up to here. And then my 76 is 0.1. So now we have a wall right here. Maybe we can try to, you know, to have the wall a little bit smaller. The way to do it is we come 0.5 and we start grading it like that. So that's 76, that's actually something like that. So we can have like a smaller retaining wall. And then my 72, my 74 is gonna be doing something like this. And then this is gonna be my 74. Perfect. And then another 4 feet. And then 4 feet to my 70. And that way the wall is smaller. Perfect. So my wall goes from here to here. I'm gonna change this to this color. I'm gonna do 1. We do PLZZ, and that is gonna be the retaining wall. This is a construction line. This is a construction line. So yeah, basically that's the way to do it. So we still have the swell that is picking all this water, and we're creating a swell, and we're taking all the water away from the house and away from the retaining wall. And this water actually is going away from us too. So we're kind of forcing this water to go away from the retaining wall that we are proposing. Okay, so we have finished tidying up these contours to the existing ones, because remember, a constraint is an existing retaining wall. So we're kind of eliminating we are tying the existing one to the proposals. So basically, I hope you understand how to grade the retaining wall. And this is going to be 70. Then this 78 can be, we can try to shorten this retaining wall a little bit more, like that. If we show this 78 to be like that, this is 68, which is that 68. That way you shorten a retaining wall, and then 4 feet, like that. Let's save. Okay, now we can move to this side, because right now we have, let me do it this way, polyline from the intersection to here, to there, to there, to there. So we are creating this swell. Let's change that to 0.5. So we're creating this swell to take this water from this high point all the way to the back of the house. Now let's move and work on this side. Again, we're creating, this is my high point, so we have this water going that direction. And let's work on this side, tie the existing and the proposed contours. This is actually 76. So from 76, you go from 76.3, you go to 76, 74, 72, 70, and then 68. Okay, let's change these contours to the right layer. Okay, so we have this 76 that comes right here, and then 74, and then 72. So let's try to tie them out without a need a retaining wall. So to do it, you know, we can come like 2 feet from the edge of the proposed concrete, and we just tie it. So that's gonna be 76. Okay. And then we can do 2 to 1. 4 feet, 2 to 1 to 74. And then we tie it to 74. And then we 4 feet to 72. And then we tie it. And then we got 70. So this 70 actually comes like this. Let's see if we can make it. Gonna be tight. We might need a wall there, a small wall. Because we have this 68. This 68 is a constraint that we have. So we might need a tiny, tiny wall right here. Because that is, this is 70. And this is my property line. This is my property line. Okay, that'll work. So we got this 70, we might need a wall there. So we got this 70, we pick this 70, we reroute it, and then we release it again, and that goes to the, you know, this buffer, and it goes around, we pick it up again, and we bring it back to the house. So this is 68.9. Okay. This is good enough. And this is my 78. We can do it like that. 2 feet from the edge of the paving, concrete, and then we tie it back. Sorry. So we got 80, 78, 76. So let's do it. Okay. This is gonna be like 64. Again, this is gonna be like a tiny, tiny, tiny wall. Four. This is going to be on the high side, so let's do another 3 feet. This is going to be my wall. This is 68. Let's change this layer. This is going to be 68. And then it's hitting the wall. And then this 68 is hitting the wall. So it's hitting the wall and it's leaving right here. But we also need a 70. So basically what we do is, we come point 1 to here, and this is 70. Okay. this is 70, this is 68, this is 70, and this is 0.1 from the face of the retaining wall. So this 70 is traveling along the retaining wall, and then it's released right here. Well, actually, this 68 is cut right here, and this 70 is cut right here. But this is 72. So again, we need to be 0.1 we're fine. We don't need 72 anymore. So we got another wall, small wall right here. This is my property line, this is my 70 contour. Then we draw the retaining wall. 0.2 on this side. This is my little retaining wall. So that's it. So we got this wall that goes from 68 to 70 to 70. Well, we don't need this 72 can just bend and go right here. You can make this retaining wall, well, it's too close, but you can make this retaining wall smaller if you do it like that. So this is going to be your 70. Perfect. And then 6 inches. Well, this is already 68 going away from the wall. Okay. So you got this, actually this wall is smaller. Now, what happens is, remember that the maximum slope is 2 to 1. So basically, what happens is we need to be 4 feet. We need to create 4 feet around the wall between the 70 and the 72 contour. The right way to do it is you come and you draw a polyline between these 2 points until you come, 4 feet. How much is that? This is already 4 feet. So actually this wall extends up to here, because we need to be 4 feet away. Between 70 and 72 we need to be 4 feet away. So this is 4.3 feet. So this is perfect. This is the right length for the retaining wall. So you can have a 2 to 1 slope coming down and coming down. But actually the right way to do it is you come down and then perpendicular to this line. We need to be 4 feet. We're almost there. So the wall needs to be a little bit longer until you provide 4 feet. Now if we do it like that, you need to come right here and then perpendicular to this line, and this is going to be 467. This is perfect. So this is the right length for the retaining wall. PLZZ or 7.2. All right, now we can move, let me save. Now we can move to the downside of the house. So this is 65.8, which is the same elevation, but this is 66, and this is 68. So basically, if this is 66, this contour is 66, we need to be 68.8 somewhere So what we can do is we need to be 2 to 1. So from 66, again 2 to 1, from 66 to 65.8, we're talking about 0.2. At 2 to 1, we can be 0.1. So when this contour hits the retaining wall, we can be 0.1 from this point. Look how tiny it is. So basically this wall, you can cut this wall right there. And we are basically more distance than we need. We are like 2 feet. So we can cut this retaining wall right there. And this is gonna be 60. This is gonna be 68.8. Let's change this. We don't need that many numbers. So let's do it like that. We're almost done. So this is 70. And this is 68. And this is 66. Let's copy that. This is down. Perfect. Now, but this is what is this contour. This is 64. Okay, that is 64, but we got this as 68. So basically, this 64 goes like that. So we need to create again while maintaining the same concept for, you know, the swell. We can create this swell probably it's gonna be like that. But then we can be 2 to 1 on this corner. So we're talking about 1.8 feet to be at 64. So 1.8 at 2 to 1 is going to be 0.1. So we need to be 1 foot from this corner. So my 64 is actually doing something like this. We can do it like that. And I wanna have like a flat area right in front of here for, you know, for guests when they come out of the patio. They have like a little section they can walk before they start going downhill. So let's change that. How far is that? This is gonna be almost 10 feet. Let's do 10 feet off here. $10 occupied.
Hey George, I'm heading out, okay?
Okay. Uh, 10 feet, and this is 64, so this 64 is hitting this 64. And then what happens is this is 64 right here. So we need to tie the existing and the proposed contours. Okay. I can delete this. This is a construction line. Perfect. Okay, this is 66.4. This is good. All right. So this we're providing like this swell all the way 76, 74, this swell right here. And then continues to 64 and then leaves the site. Okay guys, I think we're done. Basically all we need to do now is to smooth the contour lines. We need to smooth the contour lines. We don't have to show this 77 because we normally show just, you know, we just show the even contours, but we can do the spot elevation right there. So the contractor knows that that elevation is going to be 77, and we can delete that. We can delete that. So he can see that it's coming down, and then we can also do this. We can set that this is 79 right here with a spot elevation. So he knows that he needs to change the slope right there, and we can get rid of that one. Now we need to connect this one and this one. 10 feet right there, and then we can do something like that. So this is my 78. Okay guys, I think we're done. The only thing that it is outstanding to explain is basically this house has, you know, has a patio, and then there is a deck on top of the patio at this elevation. So basically what happens is, let's do the magenta colors again. On the second floor, the second floor elevation right here is 77.5. Now as soon as you come out of the door, the elevation right here on the second floor on the deck is going to be at this same elevation. So this is 77.1. And what happens is, again, what is this distance? $13.9. But remember, you need to come, you know, between around 2%. We can do 1.5%. So it's 13.9, 0.015. So it's 0.2. So this elevation right here is 0.2 feet below this elevation. So it's 0.2. So we got 77.1 minus 0.2 is going to be 76.9. Okay, on the second floor. Now I can assume that the elevation right here for this landing, for these stairs that go, this stairs goes down from, you know, from the deck all the way to this elevation. Okay, so basically the way you do it is, you know, the way I do it is basically you need to be at this elevation is going to be 76.9, which is this elevation right here, and then we need to come down to 66. Okay, we need to come down to 66. The architect, you know, he doesn't know how many stairs he needs. He just create this break line because he's not sure how many steps he needs. But we can tell him. We can tell him, hey, you need this many stairs. The right way to do it is this elevation right here is going to be 76.9, and then you come down with the stairs. Remember that the stairs, according to our restraints, the stairs are the landing is 11 inches, but the rise is 7 inches, or 0.58. Okay, so we come right here, and this elevation right here is 76.9. And then you start coming 0.58 all the way down to 60 to 66, which is this contour right here. Okay, so you got 76.9 minus 58. This elevation right here is gonna be 76.32 minus 0.58. This is gonna be this elevation right here is gonna be 75.75, and then minus this elevation right here is gonna be 75.16 minus 0.58 is gonna be 75.58. This is gonna be 74, and keep going all the way down till you get 60, 66. Okay. So and that way you can show, or if you want to, it's not a requirement. I just want to show you that because that's the way to do it, but we're not required to show that information either. I just want to show you how to do it, how to do the stairs, especially when they are outside. I mean, if you want to, that's okay. Otherwise, the contractor might be able to pick it up. How many stairs he needs with that information that we got given him. Okay. Now, to finish this, we just need to smooth the contours. In nature, there is no need. There is no sharp contours. They all are, smooth. You just smooth it with radiuses. Okay. I like it. Now you label it. And this is gonna be, it is a retaining wall, but we call it foundation because it's part of the foundation of the house. And basically what happens is, on this side, we're gonna be like 68, 69, because this is 70, and this is 68.9. So this is gonna be like 68.5 on this side. But on this side, we're going to be at 63. So this is going to be higher than this one. So, but we don't need to show that. I just want to show you how to do it. PLGZ. We go 0.2. So we can show that is part of that. This is. Can delete that one. I mean, if you want to, we can create a swell right here. I don't think is needed. Basically, what we need to do is we can provide like some kind of riprap along here to make sure that this water doesn't erode this slope. I would try to make. Well, what is it's going to be hard to make because we got this 70. And this 70, this is an existing. This is going to be an existing buffer, so we cannot grade from this line. We cannot grade over here passing this line. We need to keep it. So I will just leave it alone. Just let this water. Probably what's going to happen is this water is going to. What we can do is for this water to be away from us, And the way to do it is we can create like a swell if we want to. Like that. We are not touching the buffer. And we can connect that one to that 70 right there. So basically what happens is this water is going to come down. And over here we're going to force this water to turn and go away from us. We can do that. And that way we're forcing this water to go in that direction, and this water won't go in that direction. Okay. So we'll make this 70. You see how simple it is? You know, you always need to show the, you know, the water away from buildings, away from walls, away from everything. You don't want this water to be touching your house. So that's basically a good way to do it. Okay. Guys, I think I'm done. If you have any questions, please do not hesitate to call me or send me an email, and I'll be glad to answer. Don't forget, we need a door right here. So guys, I hope you like it, and if you got any questions, please do not hesitate to call me. Thank you so much.